Question 7, we're looking for the angle APC. So APC. The angle that we're looking at is at P. Okay, it starts again to fill out as much information as we can on the diagram. First of all, we have I think a double angle theorem here. So we've got the angle AOC is 84. That meets in the center, but A and C also subtends at D. Okay, so this should be double of the angle that meets the circumference. So this is going to be half of that, 42 degrees. Now if you look, we've got a triangle here, ODC, and the line OC is a radius. OD is also a radius. So we've got an isosceles triangle. So if OD is equal to OC, then those two angles must also be the same. From there we can start to work out the angle that is here. 42 at 42 is 84. 180 degrees, take away 84, gives me 96. If you can see, we actually probably could have spotted that right from the very beginning. In fact, just write 96 degrees there. We've got a straight line here, 84 plus 96 makes the 180 degrees required. So there are different ways around all of these different problems. Okay, the angle around this centre here, I've now got 32, 96 and 84 degrees. I should now be able to work out that red angle there. So I've got 96 degrees plus 84 degrees. Well, I already know that's 180 degrees. So actually, let's just look at this as a straight line. I've got 32 degrees here. What is the missing angle? Well, 180 minus 32 is 148. So that red angle must be 148 degrees. Well, once again, you should be able to spot we've got another isosceles triangle. I'll draw this one out this time. The triangle AO, OB, BA is an isosceles triangle because BO is a radius and AO is also a radius, so that length is equal to that length. So we've got 148 degrees. We've now got two equal angles. We've already used 148. What is left is 32 degrees. That has to be split equally between two angles. So 32 divided by 2 gives me 16 degrees. Each of those angles must be 16 degrees each. I'm writing them below just because I haven't got room to put them on the angles themselves. Okay, what I'm trying to work towards here is I'm starting to spot I've got a triangle that might help me with my solution. I've got PD, DA, AP. Okay. Now already I can see that in this I've already got highlighted for me this angle here being 16 degrees. We've just worked that one out. And I can now start to see how I might be able to calculate that angle there. If that's 42 degrees, that must be 138 degrees. Angles on a straight line must add up to 180 degrees. So if the angles in a triangle must also add up to 180 degrees, I should now be able to calculate this angle here at P. Well, 138 plus 16 gives me 4 carry 1, 3, 4, 5, 154 degrees. 180 take away 154 gives me 26 degrees. So the answer to our question is 26 degrees.